let's take a look at differentials because they can help you see that linear approximations are just a simple application of what you've already learned in Chapter 6 about calculus. So if I take the derivative of this expression, and I'm going to use Leibniz notation, I get dy over dx is equal to f prime of x. Now, generally speaking, this is an instruction, not algebra. It's not literally dy divided by dx. But if I rewrite this expression as dy is equal to f prime of x dx, I can clearly see and simply see that the change in y is equal, that's what dy is equal to the change in x multiplied by this proportional factor, which is the derivative, f prime x, and you can think of that as the slope of the tangent function, and we're walking along the slope of the tangent function to get our approximation of f of x at different points, different x values. Now we still have y is equal to f of x, and if x is changing, how do we write that? Well, we could say that f of x plus the change in x, notice that both these are inside the function, so we're changing the value of the function, are approximately equal to f of x plus f prime of x dx, approximately. Not exactly, but approximately equal to. Now let delta y, little triangle y, be, maybe I've drawn that too close, be the actual change in y. Then we can write delta y is equal to f of x plus dx minus f of x, and that whole thing is approximately equal to dy, which is equal to, and maybe I need to make sure that these are really good looking approximations, is approximately equal to dy, which is equal to f prime of x dx. So if we want the actual, here is our formula to find the actual, and that should look familiar from an iClicker question that we did in previous sections. And it is approximately equal to this thing right here, which we define as dy. Where does the dy come from? Well, it comes from way, oops, delete a little too much there. It comes from way back up here. Oh, didn't do that right either. It comes from way back over here, which is just me taking the derivative of this thing here and then moving that dx around. So let's not think of it as multiplying both sides by dx, but it kind of looks that way, doesn't it? And here, it's not even an instruction, it's actually just a notation for the derivative. Let's walk through what we've learned about differentials through a diagram. So I'm going to start off, and let's say we're interested in a specific point. We want to find the value of y at a certain point, and we're going to use some information to get it. So let me start by drawing a tangent line. So let's suppose that the tangency is right here at point A, and maybe we're interested in what y is going to be over here at point X. if I walk over here, we've got f of a right there. Remember this black line here, this is f of a. And this blue line, that's our tangency. It's f prime of a multiplied by whatever x value. And that's our tangent line. The distance between a and x here is dx. And if we continue this horizontal line here, we can see that if we walk along the tangent, the difference between, say, we'll call it point A and point B is dy. Now remember that dy is our approximation of the change in y. Right? And if I walk out over to here, I'm going to get, well, I'm not going to get, we get f of a plus f prime a. Give myself a little more room here, multiplied by x minus a. And you can see that the difference between these 2 points is going to be dy, which is equal to f prime of a x minus a. What's the true value? These are approximations I've talked about so far. The true value is right here at f of x. Right? If I walk over here, this is f of x. And if we look at this distance all the way from what we'll call it point C to point B, that is our actual change in y, which is the triangle, the Greek letter delta, triangle y. So our approximation is going to get us close, but it's not going to be the actual change in y. So notice, I'm right in the top left corner here, notice that the change in y minus dy is equal to the error of, or maybe instead of, I'll say the error in the approximation. So we know it's not perfect here, just looking at the diagram. If we could actually measure that error, and the distance is the distance between point C and A. Here's how the textbook illustrates it on a diagram. You can look at that. Maybe you find it cleaner, and maybe you find that useful as a summary slide. I suggest you try and write it out yourself, draw it yourself, think about it, make sure you remember what's what. In terms of language, you can read the slide in front of you. F prime of x is known as the factor of proportionality. And remember that dy, that's our approximation of the change in y, not the actual value. The actual value was that triangle y, delta y. If you're ready, try this problem yourself. If not, let the video keep going and we'll go through it and solve it together. So we want to find the approximate change and we want to find the actual change in this function 2x squared. And we're interested in looking at the change when x moves from 3 to 2. So that's going to be our x value, that's going to be our a value. We know that f prime of a is going to be equal to 4x, which is going to be equal to 4 times 3, which equals 12. And x minus a is going to be equal to 1. And so let's take a look here. So let me write out the actual formula. If we want dy is equal to f prime a times dx, and that's going to be equal to 12 times 1. So we just get 12. Now x minus a is going to be equal to 2 minus 3, which equals negative 1. Combining this together, we get dy is equal to f prime a, x minus a. And so we have 12 times negative 1, which is equal to negative 12. So that got our dy. Now we have to try and find the change in the actual change in y. And if we want to find the actual change, we're going to have to write out f of x plus dx minus f of x. Or in our terminology, we're going to have f of a plus the change in x minus f of a. So we end up with we end up with 3 plus negative 1 minus f of 3, and that's going to give us 2 squared minus 3 squared. So we end up with 8 minus 18, which equals negative 10. And so the correct answer is C. So we've got the estimate is negative 12 and the actual is minus 10.